Hi everyone, welcome. My name is Samu András and I work at Supercharge, and on today's meetup I'm going to talk about ARKit and indoor navigation. So who has used navigation software like Waze or Google Maps? These are really cool navigation softwares and it's really easy to use. You can just type in the address and it will show you your location on the maps, and it will give you a turn-by-turn direction to your destination. And we all used it and we know that it works great outside, but wouldn't it be great if we could have the same kind of experience inside? And only just a small problem that we don't have roads in buildings, so we cannot say, like as we usually hear in Waze or Google Maps, that turn on to Andrássy Street and go forward and make a right turn to Nagykörút, because there are no named roads. And to overcome this, what we can do is to overlay the paths and directions to the environment with ARKit, with augmented reality, and then we can display an easily followable route to our users. And when ARKit and augmented reality was released and came to the market, many developers started working on prototypes, and here is our favorite. This is from a guy, Andrew, and you can find this on Twitter. This is a really cool example in a big shopping market, and this lets you find the product you're looking for when you're lost in a maze of the aisles. And this is also a very great use case. But I was recently in one of the newly opened malls in Budapest, in Etele Plaza, and I was looking for Jysk. And there are these kiosks when you can type the store name and it will give you navigation, but I was very confused and I was lost for 5 minutes looking for the store. And I wish I had an application which could have used AR and just guided me to the store. So navigation in big malls and big buildings would be also a very great use case for indoor navigation. And one I want to mention is, we all know when a meeting is coming up and you see that the meeting room is booked, and it's a meeting room that you don't go often, and you just wonder, oh, which floor is it? And in those scenarios, it's also a very good use case when you're trying to find your meeting room. Also, it can work other ways, that it could show the available meeting rooms and other scenarios as well. So we really liked the idea at Supercharge of indoor navigation, and we wanted to explore more in depth, and it was a perfect fit for our in-house research and development program. It's called Future Supercharge Labs. And in part of this, we can try out new technologies, new ideas, and we wanted to investigate what are the ways we can create an indoor navigation experience. And we also wanted to create a small prototype so we can try out and show it around and ideate around that. So we set out 3 areas that we wanted to explore. The first is, how can we create a map? How can we map a building? The second was that we need to locate our users inside. So that's a very important area we wanted to touch. And the last is finding the best route. So finding the best route for the users to navigate to their destination. So let's start with creating a map. When we started doing this, it was that time when Apple released its Room Plan API. It's a new API that was released 1 or 2 years ago. And we instantly wondered that could we scan our building and could we create the map with 3D scanning, and we wanted to give it a try. And we were amazed how it well worked. So if you're not familiar with Room Plan API, it's an API that you can integrate into your app, and it uses machine learning, and it uses the LiDAR and also ARKit to map the room and the environment around you. And it using machine learning and LiDAR, it detects walls, and it also detects automatically the door openings and windows, and even it can recognize common furnitures like chairs or fridge or tables. So it's a very handy API which you can easily integrate to your app. So we really liked it because it's easy to use. We could integrate into our app, and it gives a very accurate 3D model because it uses LiDAR, so it's pretty accurate. And also, if you don't want to integrate, you can use it as a standalone app, and it can export a 3D model, which is in the USDZ format. It's the Apple's universal 3D file format, and it's very handy because RealityKit and SceneKit also supports it, so you can directly import it into Xcode, and you can play around with it. So this is just a picture of our first attempt, and it turned out really great. This is actually the 5th floor, but it has the same layout as this floor. As you can see, we are currently sitting here, and this would be the playing area over there. And this was done in one scan, and it turned out pretty great, so we could start using it as a map of our office. But one thing I want to mention, that LiDAR and this room plan API has a hard time with big window surfaces and mirror surfaces. As you can see here, one wall is missing. It's because it's a corner window, and LiDAR just goes through it, so it cannot detect very well. So these were our findings. But when we saw that let's scan the whole building, we were a bit troubled because Apple recommends that it can be used for small apartments, max 2 or 3 rooms. So scanning a whole building would take us different scans, and we could merge them together. But in this case, we found that maybe it's better to use existing architectural plans if they are available, because you can easily convert them into maps, and it can be more accurate because the building was built around them. And one thing is that if you try to map a multi-floor building, you should connect each floor because the user might navigate from one floor to another. So you have to indicate the lifts, staircases, and other ways they can travel between them. Yeah, this is just an example of a big office plan, and this would take like many attempts to scan the whole. So in buildings like these, it might be easier to convert the architecture plan to your map. Yeah, so let's talk about locating the users inside. This was the next challenge for us. And for navigating, it's very important that you always know a live location of your user, so you can always display the right directions and update the progress, how they approaching their destination. And we wanted to investigate 4 different methods to locate our users inside. The first was GPS. The second was scan point cloud data, beacons, and AR reference images. With GPS, we know that it gives us a very accurate location outside, but we anticipated some troubles inside because there might be a worse coverage or even no coverage inside buildings. But we wanted to give it a try because SceneKit supports true north as an orientation, which works very great with GPS because you can set your scene orientation to north, and with a trick you can place objects and nodes in the scene with actual GPS coordinates, so it's very easy to build up a map with coordinates. And when we tried it, we found that it has a very bad accuracy inside. Even close to windows, it was not usable, and inside of buildings, it sometimes displayed that we are in the other building. So for navigating to one room another, this is not very useful. But we found a good use case for it. So when you're trying to find the entrance to a building or transitioning from outdoor navigation to indoor navigation, GPS can be very useful, even in AR navigation. So the second method we tried is called scan point cloud data. And basically, this is what ARKit does. When you start an ARKit session, it will scan around your environment and detect feature points and try to save them and know, based on the feature point, where you are in the space. And with ARKit, you can save actually those feature points into an AR world map. And later, when you are in the same environment, you can load that map. And ARKit will try to match the new points you scan. So you are in a new session. You start a new AR session. It will scan the feature points. And it will try to match those feature points to a map you try to load. And if it can match, it knows that you are on the same location. And it can relocate yourself. So based on that, you can determine the position of your users inside. And this is very great because you can serialize these maps and you can actually distribute them easily. So you can scan an environment and then upload to a backend solution so other users later can just download the map and then instantly relocalize themselves and don't have to pre-scan the location, just use it. Yes, we tried it, and we were wondering how well it works because this creates a snapshot of the scanned location. So if you move things around, this might cause a bit trouble for ARKit, and we tried it in the office to scan it, and then we moved chairs around, people walked into the scene, and we were trying how well it recognized the same scene again if there are changes in the scene. And it did not work great. So it was a good experiment, but we found that this method is very sensitive to changes. So when you try to relocalize it, and like in case of office chairs, you roll around, and maybe they are in different position or different people in the scene, it has a hard time recognizing it. And also, we found that it's not very scalable. If you try to scan a bigger location, it means more feature points, more data. And when you try to, when ARKits try to match the new points to the big cloud of data, it's very computing intensive, so it takes a while to relocalize. But on the other hand, it's a native Apple API, so it's easy to use. And the maps are easy to distribute, and no special hardware needed. You just need your phone, and you can relocalize yourself in the space. The third method we tried is using beacons. These are little devices which emitting a signal, and the phone can, based on the signal, measure the distance between the signal and the devices. And if you put many devices around the room, on the walls, or other surfaces, you can calculate the distance. Based on distances, the phone position. We used these little devices. They are battery powered. Actually, you can after the meetup, you can see them. They are here, and you can try them out. These are using so-called ultra-wideband, which is a new technology. I think it's from iPhone 12. It uses the U1 chip. And this is a new technology. Later, older beacons used Bluetooth, and they measured the Bluetooth signal strength and calculated the distance from that, but that was not very accurate. But this ultra-wideband UWB technology provides a high precision, and it uses a time of flight method to calculate the distance. So it measures how much time it takes the signal travel between the beacon and your device, and from that it can calculate the distance. And if you have a map of the beacon's position around the room, you can use triangulation or a multilateral localization algorithm, which is basically the same, but with more points. And you can calculate the device position. And we found that this works pretty great because your phone can auto-connect to the beacon, so you don't have to connect to each beacon manually. But if the phone discovers the beacons, it can auto-connect. And using that, it can locate them instantly with a precise location. Because these devices are battery powered, they emit a signal every second or so. So this localization can be very spotty. So you can get a location update every second, which is not a great user experience. But the good news is that you can combine this with ARKit. So between those location updates, you can use ARKit to so ARKit can provide you a live update on your location, and between those locations, ARKit is very accurate to fill those gaps in. But on the other hand, this needs a special hardware, which means higher cost. So if you want to equip like a larger office building, this is a thing to consider. And also, you have to maintain them, so you have to replace batteries, or they are corrupt. You have to replace the hardware, so this is a drawback. And also, we tried the AR reference images, which is similar to beacons, but it's an easier solution. You can place images on the walls, and if you upload those images to ARKit, you can calculate the distance. So ARKit can recognize those images, and if those images are recognized, ARKit can tell you the position, rotation, and the normals of that image. And from that, you can calculate your position in the space. So if you have the images as well as like in the beacons on your virtual map, and you know which image ARKit just recognized, you can calculate your location indoors. And from that, you can use ARKit's location updates to have a live location update. So this needs images around the building, and you have to add those images to detection images in your ARKit application, and ARKit will automatically call a delegate function when an image is recognized, and from those recognition you can get the position of your users. And I want to show you a quick demo here. This was using these AR reference images. As you can see here, we've placed an image, and from that it instantly recognized the position, and we are following a static route. Also with images, because you recognize once, and then you are basically using ARKits to provide location updates. It can have drifts on longer distances, so you can place multiple images, and if you rescan them, you can get a new position update. So this can, with this method, you can avoid drifts. And here in the video, we are actually navigating from one floor to the other, and to find a calling booth. And we wanted to try, if you are taking a lift, how much confuses ARKit, because ARKit uses the inertial sensors like accelerometer and gyroscope. And actually, you can see here those error messages that tracking is limited, and it pretty much confused for the first time, but it came back to normal. And here we are entering the second floor, and we rescanning another code, and our route is back on, and we can follow it easily to find our calling booth. Yes, and the third part is finding the best route. And this is a very complex and large topic, which we didn't really touch on because of time pressure. And this is a topic where you have to, using your map, calculate your route from the user position to its destination. And for the sake of the demo, we used static routes. But later we investigated how could we integrate to existing solutions, or you can choose your own route planning algorithm or a best known algorithm to plan your shortest route. And this is a topic which we will like to discover more in depth in the future. And our takeaways from the first two topics is if you want to have a general indoor navigation, we found that beacons and AR reference images working very great. And this scan point cloud data wasn't reliable enough to use. And for small AR experiences, scan point cloud data and AR reference images can be a good solution. With small AR experiences, I mean, if you would like to provide a AR guidance for the kitchen, or like for a machine, or like a smaller scale, you can easily use scan point cloud data if it is a static thing and doesn't change much. So thank you for your attention. If you have any questions, please ask.